Okay. So how's everybody doing? We had the test Saturday. Overall, y'all did awesome. I was very happy with it. A couple of the things you missed, I mentioned this in the announcement, but there was algebra was actually the killer for us. So we did better than most of the sections. There was one section that kind of beat up on us a little bit, but as far as scores go, but for the most part, and she wrote the test, so um, but for the most part, it was actually it was very good. I was very impressed with how you guys are connecting the math to the drawings. And then, of course, our quiz this week was a survey. I'm going to address some of those concerns. I do change the course, but a couple of things that came up that I can't change. I can't change the fact we're using a lot of platforms, and if it was up to me, we'd be using Twitch and Discord and Canvas. But of course, we have WebAssign. People are complaining about the fact that there's so many platforms, and I know, and I hate it. But it's a real pain in the neck to manage too. So it's not just you making sure that you've got everything. Last semester, I tried to do it where I posted when I posted stuff to Canvas, I posted stuff. But I'd forget, and then people would miss it and be mad at me. It was just easier to tell you to, subscribe. I wish I could use, one streaming platform and have the videos on the same platform. But, one stream's better than the other, and one stores videos better than the other. And it's just, I know there's too much stuff to go running around. Another common complaint in the thing is the pace of the course. There's not a whole lot I can do about that just because it is just boom, 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 boom. Some people are like, well, I work all this. Yeah, I think I was upfront with the amount of time. Some of the other suggestions, though, the problem sets are too long. I know. I told you it'd be a few weeks before it. If you look at the new one, I think it's shorter. I go on and on too much. Yeah, I know. This being a case in point. And I'm working on that. But there were other suggestions, and I will address those as I find solutions to those problems. Are there any questions? It's fine if you submitted the survey quiz late. That's fine. That's a question. Okay. So I wanted to start by going over, and one of the things I am doing is I am going to do more examples and try to work on the algebra. I actually thought about it if there was a way for me to make videos that people could not do. I'm not sure about that. I'm not sure how much time it would take. I'm going to try to get with another instructor, maybe that we can, do videos together with more examples so that we'd have more examples floating around for people that want to see step by step. I know some of the WebAssign videos aren't very good. And as much as I can work on that, I want to work on that. So people were mentioning those things. But what I really wanted to start with was going over the two commonly missed problems here, and that was these two. So I'll start with this one. The other one was this using the definition of the derivative proved that thing. I'll do that one second. Let's start with this one. Let's move you away. Let's see. Go away. Go away. Thank you. Let's talk about this one. Now, this one is hard. There's a bunch of things going on with this one. This is, of course, the definition of the derivative. This is, of course, the definition of the derivative of f of x equals 1 over x. Okay, and there's a couple pieces in this. Let's just start with this. I know that someone's having technical issues, and I don't want to say his name, but if you could point him in the right direction, I'd appreciate it. All right, so I have that the limit of 1 over t. Now, the first little algebra trick here is that I have to take a common denominator of this thing to fix the top. And then the other big thing is this t minus x on the bottom. Now, I don't know if you remember or think this way, but if you remember, a over b equals a over 1 times 1 over b, right? I could slide that out from under there. And that would equal a times 1 over b. So let's make this whole top bit here be a. And do this. Where's my purple pen? There it is. Okay, so let's deal with that first. So let's do 1 over t minus 1 over x times the quantity 1 over t minus x. Okay, that's the first thing that we're going to do, is we're going to kind of get rid of that. Now, I could multiply this through, but that's just going to make my common denominator a little bit more complicated. So let's do the common denominator next. I'll write just what I'm doing here. So I'm going to take a common denominator of this term here. I'm going to wind up with the limit as t goes to x of, now I'm going to do t over t here, x over x here, and I'll wind up with x over xt minus t over xt. And I've still got this 1 over t minus x floating around. Okay, so now that I took the common denominator, well, the whole point of doing that was to do this. Okay, now here's the second part. This term and this term look a lot alike. In fact, this term here is this term times -1. So that's the other big algebra trick that's right here. I need to factor. So let's see, deal with bottom is this one. I need to factor out a -1. And now this term has a negative x and a positive t, and this term has a negative x and a positive t. Okay? Ugh, that's annoying, but now they cancel. And now I get the limit as t goes to x of -1 over xt. And now I can directly substitute, which equals -1 over, I'm going to make this go here. This becomes x times x, which equals -1 over x squared. So there was a lot of algebra that you might not remember from that. And if you missed part of it, you missed the whole thing, which was really annoying on this problem. I mean, there wasn't, if you tried to multiply by the conjugate or did all these other things, you just kind of got lost. Okay. And there was just, come on, change the color. It's not going to. It's not frozen. So, okay, so it's working on this. I don't know. So there were 3 kind of algebra tricks. All right. So now that we see the solution for this, how do we feel about it 1 to 5? Let me see here. How can I make this work? Okay. There is another way to do it, and that's to recognize that this thing actually equals the definition of the derivative. So you could have also done this if you wanted to. This would have been just too clever by half, but you could have done it. The other way to deal with this issue is to turn it into an H problem. All right, so you should have said lim t to x, t over t minus x. Okay, sorry. 1 over t minus 1 over x over t minus x equals f prime of x for f equal 1 over x, f of x equal 1 over x, which equals the limit as h goes to 0 of f of x plus h minus f of x all over h. And then you kind of write over here, I do, because so f of x plus h equals 1 over x plus h. So you could have done it this way if you really wanted to. Again, this is a little bit too clever by half, but it is. It goes to 0, 1 over x plus h minus 1 over x all over h. Now, if you did this, you would have gotten partial credit for understanding that what you were trying to do was this limit was the derivative. So you could have gotten a little bit of some points here by doing this, by recognizing what you were looking at was the derivative. And then you get right here, you still have to take a common denominator, but some of it's more natural. So you get x over x plus h minus, I'm going to do this kind of in one step here, minus x plus h over, there should be an x here, shouldn't there? Minus x plus h over x plus h times x, because the x was there from before, times 1 over h. So then when you combine this, it's kind of it becomes a little less annoying. X minus and then x plus h. You have to remember to distribute that negative. Something I forgot to do this morning when I was doing this. And now those x's are going to cancel, and you're going to be left with a negative h on the top. And that's a little more natural because it's easy to recognize that the h's cancel by a factor of -1. And you're left with... So that is one fewer trick, although you have to be careful to keep track of that negative. And that equals the limit as h goes to 0 of 1 over x plus h times x with a negative in front. And that equals, I directly substitute in there and I get the -1 over x plus 0 times x, which equals -1 over x squared. So there was another kind of overly clever way to do that. Okay. Okay, so the question is, when I first started working on it, how did I just cancel the denominator? And I didn't. What I did was I slid it out from under there as a fraction. Okay, so I have this kind of identity here that, you know, a over b equals a over 1 times 1 over b, right? So like 2/3 is the same thing as 2 times 1/3, in a sense. In this a here, in this case, This a here was 1 over t minus 1 over x. So what I did was I just kind of slid that out from under there, just like this 1 over b trick, and then I pulled everything that was on the top down. Because this would have become this whole thing over 1, and then I just kind of, the divide by 1 does nothing. And I just kind of slid this out, if that makes sense. Okay. That's a nasty piece of algebra, but it's kind of a way to keep track of those things. Okay. Are there any other questions about it? It's a good question. Yeah, the last one I pulled out that -1, and I actually did the same thing here, except it was just -h, right? There was nothing, it was obvious that they were the same thing, that -h and h would cancel. Here it wasn't so obvious, so it was kind of a you had to see that, and it's not the easiest thing to see. So this one you have to, keeping track of that -1 is a pain, but you can do it. People commonly forget to distribute that one, that negative. But it is what it is. Any other questions? Good question. Okay. Oh, this one's a little bit of a pain. What I'm going to do is I'm going to rewrite the problem here so it's in our kind of format that we like. So what I want to do is I want to kind of say let f of x equal the square root of 2x plus 5. Want to show f prime of x equals 1 over the square root of 2x plus 5. I just put h there instead of 5. Strategy. People were complaining about my handwriting, and I agree. If someone had told me in kindergarten, hey, concentrate on your penmanship, your students may need it in the future, I would have said, what? What students? So it's a valid criticism. I've actually worked on it. I spent one of the things when you start teaching is you have to start working on your X's and you have to start writing lines between your Z through your Z's and stuff, and your 7s have to look pretty. You actually have to work on this anyway. So now I've got, and my strategy, I'm going to use H definition of derivative, or h to 0 definition of the derivative. Yes, want to show. Yeah. So I want to show that my strategy is going to be use the H definition of the derivative. Okay. All right. So what I'm going to start with the first thing I'm going to do is I'm going to state what f plus h is because I'm about to use it, right? So I'm going to say f of x equals, because I don't want to confuse myself. So I'm going to say f of x equals 2x plus 5, f of x plus h equals 2x plus h plus 5, all under a square root symbol. So I'm going to make sure I don't mess that up first. Okay, and then I'm just going to do, okay, f prime of x equals the limit as h goes to 0. F of x plus h minus f of x all over h equals the limit as h goes to 0. Now I sub in my two things that I put up there. 2 times x plus h plus 5 minus the square root of 2x plus 5 all over h. It's kind of an annoying substitution. That's why I do that first. Then what I'm going to do is I'm going to say, okay, the limit as h goes to 0, I'm just going to multiply by the conjugate. All right. And then when I do that, of course, I wind up getting rid of this thing on the top. The square roots on the top go away. And I wind up with this thing, 2x plus h plus 5 minus the quantity 2x plus 5 all over h times 2. I'm going to have to square root that. The square root of 2x plus h plus 5 plus the square root of 2x plus 5. All right, that's annoying, but it's there. And remember to leave when you multiply by the conjugate, remember to leave the denominator as it is. I mean, not as it is, but, don't multiply it through, just leave it. Because the whole point of doing that is to isolate the h. So I'm going to multiply out the top. Times blah, blah, blah. Okay. And a lot of stuff on the top goes away. And then I'm asked with the limit as h goes to 0, 2h over the unpleasantness. And I'm not multiplying anything. I'm not multiplying this out based on the principle of the thing, okay? When I multiply by the conjugate, the whole point is that I don't have to do anything to the bottom. Well, it's not the whole point, but usually I don't have to do anything in the bottom. And the 2's cancel. The h's cancel. Not the 2's. So now what I'm going to do is I'm going to directly substitute in for h. Oops. No more limit. We're getting rid of it. 2 over, and this is going to become the square root of 2x plus 0 plus 5 plus the square root of 2x plus 5. And of course, this piece right here just equals 2x plus 5. So that equals 2 over. Let me actually write that out because that's a little weird. 2x plus 5 plus the square root of 2x plus 5. And that just equals 2 over 2 times the square root of 2x plus 5. The 2's cancel. and I wind up with 1 over 2x plus 5. So d over dx of 1 over, the square root of 2x plus 5 equals 1 over the square root of 2x plus 5. And I didn't square it, I just did that. So I need that one again. Fun! So the big problem with this, it was intimidation, and just its length. It's easy to drop something in here and do it incorrectly. Okay? The length of this problem is really long and really intimidating, takes a lot of time, and it's just, if you mess something up right here, let's say you accidentally put a minus down here, it would mess up the whole problem. You'd wind up with 1 over 0. So it's this, I mean, I'm not a fan of this problem. I as a matter of fact, I hate it. I wanted something else here, but I lose. But it's just these, that's not to say this is a worthless problem. This is a great problem for demonstrating the use of the chain rule. But it's just not, it's just a long problem. So now that one's worked out, how do we feel about that 1 to 5? So the long, I don't want to say that word. We'll just say the long A derivative. How do we feel about that one? It's just, there's a lot of places to make mistakes. And it's not a very illuminating problem, but it is a problem. Okay, are there any questions about this? All right. So as I said, those were the two that you guys seem to have trouble on. That I mean, other sections had trouble on them too, but you guys did very, very well on the proof where you had to realize that you weren't doing the proof, and the other proof where you realized it was 2 cops. You did very well on really a lot of the stuff in the test. I mean, there was a lot of stuff that was really hard in here, and you guys did very well. You didn't, for the most part, you didn't try to factor the thing that couldn't be factored when you did the limit as t goes to infinity. You just subbed it in and did nothing else. A lot of you did nothing else matters, which is beautiful. Negative t squared over t cubed, and dealt with that. Your statements were gorgeous. Anything with a picture in it, you did very well as a class. It was algebra that just got you all sometimes. So yeah, that's the only thing I'm kind of concerned with. So in the future, going forward, tonight at 7, I was going to start the product rule stuff, but I'm actually going to stop and do some of the algebra for the power rule, using the power rule, some of the algebra tricks, because they do show up, especially with those like fractional exponents and negative exponents and stuff. So I am going to review some of that algebra and do a bunch of examples using that algebra so that you don't, so that when you see them, you're not, because I assume that the next tests are all going to have a bunch of these little computations in them, and I want to make sure you're prepared for it. So, are there any other questions? Okay. All right. And I realized, right before the test that one of the questions that they put on here was actually one that I asked you in a quiz. I mean, I think it's got the same numbers, doesn't it? Oops. Oops on her, not on me. Any other questions? Okay.